This device right here has sent me down the deepest rabbit hole, and that's because this is a source of free energy that has a very mysterious history and could be linked to UFOs.
But for several years now, a small group of scientists here has been investigating a strange new space-age metal, a nickel-titanium alloy called nitinol.
In cold water, nitinol turns soft. Bend it and it stays bent, but in hot water it springs back with forces as high as 55 tons a square inch. No one knows quite why this happens. Several years ago, McDonnell Douglas began experimenting with nitinol in the form of springs. At room temperature, the nitinol wire springs bend easily, but in warm water they spring back, thus forcing the wheel around. Even stranger, nitinol wires get stronger the more they're used. They develop a double memory. They not only contract in the warm water, but they begin to stretch of their own accord in the cool water. Nitinol can be trained.
And then there's this document that was written from the Battelle Memorial Institute to the Wright-Patterson Air Force Base in Dayton, Ohio in 1949. And of course, the Wright-Patterson Air Force Base is known for allegedly storing the crashed UFO that happened in Roswell in 1947, which was just 2 years before this contract was written. And in this document, they're talking about the different alloys that they're testing, and they're giving a progress report on those tests. And at this time, nitinol went by a different name.
Real, tested, proven free energy devices have existed for decades.
To investigate the potential for nitinol heat engines and nitinol power plants.
This is what they came up with, the world's largest operating prototype nitinol heat engine. It is running on warm water, and the scientists here at McDonnell Douglas say it may have an overwhelming cost advantage over oil, gas, or nuclear-generated power. Even more amazing, no one knows exactly why this machine is working because no one knows exactly why nitinol behaves the way it does. Nitinol wires get stronger the more they're used. They develop a double memory. They not only contract in the warm water, but they begin to stretch of their own accord in the cool water. Nitinol can be trained. McDonnell Douglas then went on to the next stage, using a nitinol spring belt running around pulleys, cycling between cold water and warm water. The tension on the belt drove the pulleys around. The Department of Energy then asked McDonnell Douglas to see if this device could be upscaled. A team of scientists at McDonnell Douglas's Engineering and Technology Department, led by Dr. Janelle, spent 2 years on the project, and this is the result. This engine has just been unveiled. Hardly anyone expected it would work so well. It seems to have profound implications. I asked some of the scientists at McDonnell Douglas how long it will be before nitinol heat engines will be making a substantial contribution to world energy supplies.
That's a very tough question to answer, and one of the reasons is because the economics haven't been completely studied. We still need to know the price of materials and the price of a developed heat engine. Right now it looks very, very advantageous to us. That is, we think we can convert energy cheaper than by other means, low-grade thermal energy currently being thrown away.
The nitinol engine is a fairly simple, mechanically simple device. We believe that one can couple small modules of an engine to produce engines that would generate larger amounts of power. And in principle, one could stack these things as thick as possible and come up with an engine that might generate 5 megawatts or so.
Derp, 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 screwing you over, derp, derp.
I think my favorite application in a small engine would be for irrigation. And the thing that's interesting there is that you can use the engine, the power source for the engine is merely the difference in temperature between the water that's going to be pumped and the air temperature. So almost magically you have a device that will be able to lift water from one level to another.
The McDonnell Douglas scientists say that nitinol heat engines could run on solar heated water, or on the temperature differences between the upper and lower levels of the oceans and lakes and dams. It could also run on waste heat, which at present accounts for the loss of nearly 2/3 of all energy produced in industrial nations. Research is now underway into nitinol heat engines in the United States, Europe, Japan, and China, devising ways to harness the unique characteristics of the most remarkable metal we have known. Kevin Sanders, Cable News Network, Science Report.
This wire does something kind of weird when you bend it and then put it in hot water. The wire snaps back to its original shape. Well, close to it. It does this because it's made of a special kind of alloy made of nickel and titanium called nitinol. At low temperatures, it's super elastic and can be easily bent into whatever shape you'd like. But heating it above its transition temperature causes the alloy to switch back to its preset shape. Originally developed in the 60s for military and defense use, we use nitinol for all kinds of things today. Everything from fun science toys to braces that fix our teeth and even tires for the Mars rover that spring back to shape. How cool is that?